In the previous video, I talked about the height of my trees, and I created a dot plot, actually in this case an X plot, of all the 16 trees, and we saw that it forms sort of a normal distribution, raises up in the middle and comes back down. And then I started doing samples. I showed you the first sample. I collected at random, picked 4 trees by my bowl of numbers, and I picked 4 trees at random with replacement, and then I figured out the height of each tree and added them up and divided by 4 and found that the average height, the mean height for this sample was in this case 12.3. Now I went ahead and did that for another 17 samples of size 4. Here's all my data, not that you really care, but I really did do it. For example, the first one here I got, it was unusual. I got tree number 1, then I got tree 14 and 14 and 14 again. That's okay, that sometimes happens. The average height for that tree was 14.5, and I've got the average for all of these, and I got a couple more in the back. In any case, when we take all this information and create another dot plot, or X plot if you want to call it that, here's what it looks like for of the 18 samples. These were the means, rounded to the nearest whole foot, of the 18 sample means, where a sample was of size 4. And notice what we get. We still get a normal curve, starts out small, raises and comes back down. But notice that many of the values are now much more toward the center, much more than they were in the original distribution. They were kind of spread out. Here, when we're taking making a distribution of sample means, I mean, if you think about it, it makes sense. The average of 4, isn't it more likely to be more toward the middle than not? So the main point of this is, when we take sample means and make a distribution out of them, we still get a normal distribution, but is it a much narrower, tightly packed normal distribution. In general, if I have a normal distribution that's shaped like this, and then I pick samples from this distribution and find the average of each sample, and then create another distribution from those sample means, its distribution will, not surprisingly, it will have the exact same mean. Whatever the mean of this distribution is, this will have the same mean, but you'll find that the shape of it will be much more elongated. Why? Because we're finding the average of more than one. And when we find averages, they're much more likely to be very, very close to the center. Again, this mean would be mu. This mean would also be mu. But I would have many, many more clustered closer together. This is an extremely important idea for the concepts we'll be discussing in the rest of this quarter.